Okay, let's continue with our discussion of section 3.4 on linear functions and specifically the idea of slope. And this time I want to give you guys a little bit of a taste ahead of something that we see in calculus. Specifically in the world of calculus, we're often interested in finding what's called a rate of change or average rate of change of a function. And this is the line that could be drawn through a curve in the plane if we know what the function's equation, the curve in the plane, and the points somewhere on that curve. Right? So let me illustrate what I mean right here. It says find the average rate of change of our function f of x equals negative 2x squared plus x minus 1. And I already did my point plot here, so to speak, so that you could see the function. And it said between the points whose x-coordinates are x equals -1 and x equals 3. Well, what does that mean? Well, what we're actually asking to do is, first of all, find two x and y coordinates that are on this function. The first one at x equals -1. So let's try that out. Let's say if we said at the point, with my marker working, come on, marker, at the point where x is equal to -1, we're calling this point number 1, we're going to find f of -1 to be our y value. So we're going to get our y value from the given function right here, -2 times -1 squared plus -1 minus 1. I missed a little bit there, but that should work. Okay, so let's see. -1 squared, we know that's to be +1. So this is in fact -2 minus 1 minus 1. So going through, let's see, that would make it -4. So in other words, this means that on our drawing, we would be looking for the point -1 comma 4 as a coordinate point on this graph. So I would go over here, and it looks like I'm right about here at this coordinate point. Here it is, -1, -4. That's our first point. The second point, it said to find at the point where x is equal to 3. All right, so let's evaluate our function at 3 and see what happens. Our function's value would be -2 times 3 squared plus 3 minus 1. Let's see, -2 times 3 squared. We have to square the 3 first. Order of operations says that this is -2 times 9. -2 times 9 plus 3 minus 1. -2 times 9, that's -18. Plus 3 minus 1. And if you do your addition, hopefully correctly right here, you're going to get -16 as your value. So if we go across right here, this is the coordinate point 3, -16. Right? This is what it looks like. So now we're asked, well, let's find the rate of change between these 2 points. And what they really mean is, if you could draw a line, a straight line, from this point right here at 1, 4, down to this point right here at 3, -16, what would be the slope of that line? Let me just move it down a bit. All right, we're asking, what is the slope of that line? Well, now we've got 2 points. Right? So our job is now to find the slope through those 2 points. So we're going to say our slope right here will be found by applying our formula. M equals -16 minus -4. That's our difference in y values, right? Here is y2. Here is y1. Right? And we take that over our difference in x's, which was x2, which was 3, minus x1, which is -1. And if we work that through, that's -16 plus 4 divided by 4. 3 minus -1 is the same thing as 3 plus 1. And actually, maybe I should write that out right here so you just see the signs at work here. So we got 3 plus 1 now in the denominator. So this becomes negative 16 plus 4 is negative 12. In our denominator, negative 3 plus 1, that becomes 4. And so our slope right here is negative 3. So what that means is that every time we have a change from left to right of 1, we go down 3. So this graph would show you, for instance, that if I went to the right one, I would have to go down 3. Right? Notice that the scales along the horizontal axis are not the same as the scales along the vertical axis. So it doesn't look exactly like a negative 3 as you would see on a square graph, but you get the idea. Every time we go to the right by 1, we have to go down by 3. Okay? And this works all the way down to our point. This slope, by the way, is what we refer to as the rate of change. It's the average rate of change of the function. Okay, so we call that average rate of change. Important concept in calculus.